Hey everyone, welcome to hok'stutoring. So today we're going to be doing chapter 2a, question 14, which is in regards to vector dependency, so linear dependent or linearly independent vectors. And more specifically, I'm going to show you how to do the shortcut towards the second half of the video. But of course, we'll go through the traditional way first, just in case it does come up in tech-free sometimes. I'll show you that, and then I'll also show you the shortcut, which saves so much time. And make sure you watch until the end to check that out. Right. So without further ado, let's have a go at question A, using the traditional way. So determine whether the following set of vectors, you always get 3 sets, sometimes 4 maybe, but then usually it's 3, and whether they are linearly dependent or independent. So you have a set of 3 vectors here, and let's go through the question. So how do you determine that a set of vectors are linearly dependent? So a set of vectors are linearly dependent if you multiply a scalar, so m times vector a plus, so m and n are your scalars, your just coefficients, your numbers. So if you multiply a by a scalar plus multiply b by a scalar, you add them together, and if you manage to get vector c, so diagrammatically, what would it look like is this. You have vector a and you've got vector b, and if you somehow do some as in extended or make it shorter, go the other way, so in this case maybe 2b, and as long as you can get vector c from a combination of these two, then these 3 vectors or these set of vectors are linearly dependent. So that's how you have to do it. So how do you show it mathematically? To show it mathematically, you have to be able to find values of m and n. So if you can solve for a value of m and n, as long as m and n are not 0, then that means the set of vectors are linearly dependent. So let's go through it without me talking too much. In this case, vector, so we've got m times 4, 1, 3, and then plus n times, so m and n are just introduced. You can use any letter except a and b and c, just don't be confusing really. 2, negative 1, 3, and if you manage to get vector c, negative 4, 2, 6, don't transform that, just negative 4, 2, 6 right there. If you can get from a and b, some combination of them, if you can get vector c, then these 3 are linearly dependent. So of course, adding matrices, that's just 4 times m plus 2 times n. So 4 times m plus 2 times n, that should equals negative 4. And then 1 times, or m times 1 plus negative 1 times n equals to 2, should equal to 2. So you're setting up equations, and later on we're going to use simultaneous to solve for that. So I'm just going to finish it off first. Equals to 6 right there. Okay, so you've got 3 equations, and we're going to do simultaneous to solve for m and n. And let's have a go. So we're going to use the bottom 2, so maybe second and third. Right, so multiply the second equation by 3, because we want to eliminate. So this is doing everything by hand. 3m plus 3n equals 6. And then what you do afterwards, so this was 2 times 3, and this is just your equation number 3. Then what we can do afterward is you add them to eliminate the n's. So you get 6m equals to 12. You solve for m and you're like, yes, oh, I actually get an m. Does that mean it's linearly dependent? So keep going. We need to solve for n first. To solve for n, sub m equals 2 into one of these, okay? Make sure you don't sub into the one you didn't do. We're going to talk about that soon. But sub m equals 2 into one of these equations to solve for n, okay? Not the first one, the one you didn't use. Use the ones that you have used, okay? So solve for n. And if you sub m equals 2 in over here, you get 3 times 2, which is 6. 6, bring it to the other side. You go 6 minus 6 is 0. So 0 divided by 3, which is 0. You get the same over here as well in the first one. 3 times 2 is 6. 6, bring the other side, you get 0. 0 divided by negative 3 is still 0. So this should already raise your flag that this is not dependent vectors, because if m and n, right here we said already, if m and n, one of them equals to 0, that means the 3, your set of vectors are linearly independent. So the only way to get vector c is you multiply by one of them by 0. So that doesn't make sense. You need to have a combination of both of them. Okay, n equals 0. But of course, let's just say n wasn't equal 0 and you got n equals 2. That also doesn't necessarily mean that, oh, I've got m and I've got n. That doesn't mean that your set of vectors are linearly dependent. So you need to sub into the third equation as well to see if it fits. So in this case, let's use 0, just think 0 works. So 4 times 2 plus 2 times 0, and unfortunately, you do not get negative 4. So 4 times 2 is 8, 8 plus 0 is 0, 8 plus 0 is 8, and it's not equal to negative 4. That means your m and n values are invalid. So invalid does not meet your simultaneous equation. Therefore, linearly, so your set of vectors are linearly independent. You can't combine. Doesn't matter what you do, independent. So it doesn't matter what you do, your set of vectors are linearly independent. You can't get any from A to B to get to C. So that's it. Okay, so that was the long way of doing it, and as you can already see, it takes a bit of time, a lot of space of working out. So what is the short way of doing this? So I'll go through the short way. Question B, and this takes advantage of your CAS and matrices specifically. So what you do is, okay, 3, 1, 2. If you're studying for exams or you've done vectors already, you might see sometimes that vectors, not sometimes, very often, that vectors are presented this way in terms of I, J's, and K's. And that's the same thing as writing them in this matrices form. So 3, 1, 2. What you want to do, if you want to determine whether a set of vectors are linearly dependent or independent, you group them together, 3 by 3. So 4, 2, 1, 6, 3, 4, right there. Okay? So you type this matrix in your CAS or your TI Inspire, just type in your calculator, and then what you do is you find the determinant. So this is the shortcut, the ultimate shortcut. In your exam, it's usually in the multiple choice section, and you don't want to spend like, I don't know, whatever, 3 minutes doing this question. You want to spend as less amount of time as you possibly can on your multiple choice so that you have more time to do your analysis questions. So to quickly find whether a set of vectors are linearly dependent, you find its determinant of the combined matrix or matrices. Okay, once you chuck this inside your calculator, if you get 0, so if your determinant of your matrix is 0, that means vector is linearly, so if it's 0, it's linearly dependent. And of course, if it's not 0, then it's linearly independent. You can try it. If you chuck this inside your calculator, your answer should be 5, which is not 0, so therefore linearly independent. Okay, so question B is also linearly independent. Look, all you did was just chuck this inside your calculator. It take maximum amount of time, maybe 1 minute, depending on how fast you type in your calculator, but really it's a short, very short step. Okay, and then for part C, you do the same thing. You can either do the long way, which does take a bit of time, or in the exam, if it's a multiple choice question, go straight into this calculator, determinant. So you find the determinant of this vector, the set of vectors right here. Make sure it's going down, so 1, 1, negative 1, going down the columns. B is 3, negative 1, 4, and C is 3, negative 5, 11. And then you find the determinant for that. Make sure, just go check inside your calculator, see the results. And if you do, you should get 0, which means that this set of vectors, these 3 vectors, A, B, and C, are linearly dependent. So once again, linearly I can't spell dependent. So what that means is, okay, A plus B, whatever combination of them, I can get vector C at the end. So that's it. That's what linearly dependent means. Okay. So hopefully, guys, you've learned the shortcut for this in the exam. Hopefully, it gets you that 1 mark in your multiple choice. And who knows, maybe in Tech 3 you might need to do this as well. So make sure you don't forget to know how to do the simultaneous style as well. Okay. Awesome. So I'll see you next week. Thanks for watching.